Last time we discussed parallel lines cut by a transversal. If you are given parallel lines, you can assume a line called the transversal will intersect those lines. When parallel lines are cut by a transversal, angles are created. These are conditional statements. They are in the form if P, then Q. Let's quickly review the front page of the pink sheet properties one more time. The corresponding angles postulate states if two parallel lines are cut by a transversal, then the corresponding angles are congruent. The alternate interior angles theorem states if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. Same side interior angles theorem states if two parallel lines are cut by a transversal, then same side interior angles are supplementary. The alternate exterior angles theorem states if two parallel lines are cut by a transversal, then alternate exterior angles are congruent. Before we begin today's notes, you will take a moment to fill out the back side of the pink sheet. Watch the video titled Lesson 40 Notes, Pink Sheet Properties, Transversal, starting from 6 minutes and 6 seconds. You will learn about the converse statements. These are in the form if Q, then P. Lesson 42 Notes, Proving Lines Parallel. Using the converse theorems we just learned on our pink sheet, let's answer the following questions. Here are some examples. Number 1. Given the following information, determine which lines, if any, are parallel. State the postulate or theorem that justifies your answer. First, look at the diagram. We have lines L, M, and N. Are any of these lines parallel to each other? We don't know unless we prove that they are using a postulate or theorem. What we do know is that these lines are being intersected by line P. This is the transversal. Let's take a look at 1A. It says angle 1 is congruent to angle 6. Which line is angle 1 associated with? Well, here's angle 1, and it's associated with line L. Which line is angle 6 associated with? Well, angle 6 is associated with line N. I will draw the two lines, the transversal and the angles involved. Remember, angle 1 is congruent to angle 6. Now the question here is, are these two lines parallel? Recall from the back side of the pink sheet properties you filled out today, if two lines are cut by a transversal and the alternate exterior angles are congruent, then by the alternate exterior angles converse theorem, the lines are parallel. So my answer here is by the alternate exterior angles converse, line L is parallel to line N. Let's take a look at 1B. Angle 2 is congruent to angle 3. Here's angle 2, it's part of line L, and angle 3 is part of line M. So what I'm going to do now is draw the two lines intersected by the transversal. And remember, angle 2 is congruent to angle 3. So I'll draw one arc here and one arc there to show that those two angles are congruent. We can see that angle 2 and angle 3 are inside of the two lines here, and they are on opposite sides of the transversal. So what can you tell me about lines L and M? by the alternate interior angles converse if two lines are cut by a transversal and the alternate interior angles are congruent, we can say that lines L and M are parallel. Now let's look at 1C. Angle 3 is congruent to angle 5. Angle 3 is part of line M. And angle 5 is part of line N. And this is the transversal. So I'm going to draw the two lines and the transversal. So note that these two angles correspond to each other. If we think about the two universes, here's universe 1, here's universe 2. If you're standing in this corner, it's kind of like saying you're standing in that corner. So we can say that 3 and 5 are corresponding and they are congruent. So, are these two lines parallel to each other? By the corresponding angles converse, if two lines are cut by a transversal and the corresponding angles are congruent, which they are, then the lines are parallel. So what can we conclude from what we have here? We say that lines M and N are parallel to each other. One D. Angle 4 and angle 5 are supplementary. Here's angle 4, which is part of line M. And angle 5 is part of line N. So I'm going to draw the two lines. Cut by a transversal. Here's angle 4. Here's angle 5. Notice that these two angles are inside of the two lines and they are on the same side of the transversal. These two angles are supplementary, stated by 1D. So, what can you tell me about these two lines here? By the same side interior angles converse, if two lines are cut by a transversal and same side interior angles are supplementary, then the lines are parallel. So we can say by the same side interior angles converse, line M is parallel to line N. So you might be wondering about today's lesson compared to the last one. Today we focused on using converse theorems to prove which lines are parallel. In the problem diagram, in the details provided, there's no initial indication that any lines are parallel. We're dealing with lines, a transversal, and the given information. In contrast, the previous lesson identified lines that are parallel from the start. We explored scenarios where parallel lines are intersected by a transversal, leading to congruent or supplementary angles. The bottom line here is that today we focused on proving which lines were parallel, where the lines were not parallel to begin with. Whereas in the last lesson, we focused on showing which angles are congruent or supplementary, where the lines were parallel to begin with. Let's take a look at number 2. It says find x so that A is parallel to B. This means determining which value of x will satisfy one of the converse theorems, ensuring that line A is parallel to line B. Note that we have two lines cut by a transversal. 5x plus 7 degrees is part of this angle, and 7x minus 21 degrees is part of that angle. If we look very closely, these two angles are inside of the two lines here, and they are on opposite sides of the transversal. So these two angles are alternate interior angles. Let's go ahead and set them equal to each other. So I have 5x plus 7 equals 7x minus 21. I'm going to subtract both sides by 5x. So I have 7 equals 2x minus 21. And then I'm going to add both sides by 21 to get 2x by itself. So I have 28 equals 2x and x equals 14. So my answer is x equals 14. Let's plug them in. If I plug 14 into 5x plus 7, I get 77. And if I plug 14 into 7x minus 21, I also get 77. So that means these two angles are congruent. So if we have two lines, this line is line A and this line is line B. So if I have two lines cut by a transversal and the alternate interior angles are congruent, then by the alternate interior angles converse, line A is parallel to line B. Let's take a look at number 3. Number 3 says find y so that E is parallel to F. If we look at the diagram, we can see the 90-degree angle. If this angle is 90 degrees, then that means this angle is also 90 degrees. The only converse theorem that involves perpendicular is the perpendicular transversal converse. Recall, the perpendicular transversal converse states if two lines in a plane are perpendicular to the same line, that same line being the transversal, then those lines are parallel. So this means I need to set 4y plus 10 equal to 90. So 4y plus 10 equals 90, and once I have my equation, I'm going to solve for y. I'm going to subtract both sides by 10, and I get 4y equals 80, and if I divide both sides by 4, I get y equals 20. So if I plug in 20 into 4y plus 10, I'm going to get 90 degrees. So that means I can draw the square to show that this line intersects this line at a 90-degree angle. So if we have two lines that are perpendicular to the transversal, we can say that line E is parallel to line F. So I'm going to write, by the perpendicular transversal converse, line E is parallel to line F. Number 4, if the measure of angle 4 is 3x plus 20 and the measure of angle 5 is x plus 50, find the values of x that make M parallel to N. This is line M, this is line N, and this is our transversal. Again, we know that the measure of angle 4 is 3x plus 20. Here's angle 4, and I'm going to write 3x plus 20. And the measure of angle 5 is 3x plus 50. So if we look at these two angles here, angle 4 and angle 5 are inside of the two lines, and they are also on the same side of the transversal. So that means they are same side interior angles. I'm going to add these two angles and set them equal to 180 degrees. They are supplementary. So I'm going to write measure angle 4 plus the measure of angle 5 is equal to 180 degrees. And I'm going to substitute. I'm going to write 3x plus 20 plus x plus 50 equals 180 degrees. I'm going to combine the like terms. So I have 3x plus x, which is 4x, and then I have 20 plus 50, which is plus 70. And I'm going to equal that to 180 degrees. So now I'm going to subtract both sides by 70, and I get 4x equals 110, and then I'm going to divide both sides by 4, and I get x equals 27.5. So if I plug in x into the two expressions, I'm going to get 102.5 and 77.5. 102.5 plus 77.5 will give me 180 degrees. So that means these two angles are supplementary to each other. So by the same side interior angles converse, we can say that M is parallel to N, or line M is parallel to line N. Number 5, it says if the measure of angle 2 is 3x plus 4 and the measure of angle 6 is 5x minus 8, find the values of x that'll make M parallel to N. So the measure of angle 2 is 3x plus 4, and the measure of angle 6 is 5x minus 8. So I can see that these two angles are corresponding to each other, so I should set these expressions equal to each other. So I'm going to write measure of angle 2 is equal to measure of angle 6, and I have 3x plus 4 equals 5x minus 8. All I'm doing here is substituting. I'm going to solve for x, so I'm going to subtract both sides by 3x, and I get 4 equals 2x minus 8, and then I'm going to add both sides by 8 here, so I have 12 equals 2x, x is equal to 6. Now, if I plug in 6 into these two expressions here, I get 22 here and 22 there. So we can say that these two angles are congruent. Now, by the corresponding angles converse, we can see that these two lines are intersected by a transversal, and the corresponding angles are congruent. With those conditions, we can say that lines M and N are parallel to each other. And now the final problem for today, number 6. If measure angle 1 is 7x plus 2 and the measure of angle 7 is 3x plus 22, find the values of x that make M parallel to N. Well, the measure of angle 1 is 7x plus 2. Here's angle 1. I'm going to write 7x plus 2, and the measure of angle 7 is 3x plus 22. Angle 7 is located right here. So I'm going to write 3x plus 22. These angles are outside of the two lines. So they are exterior angles and they are on opposite sides of the transversal. So what can you tell me about these two angles? They are alternate exterior angles. So I'm going to set them equal to each other. The measure of angle 1 is equal to the measure of angle 7, and I'm going to apply substitution. So I have 7x plus 2 equals 3x plus 22, and now I'm going to subtract both sides by 2 here, so I have 7x equals 3x plus 20, and now I'm going to subtract both sides by 3x, so I have 4x equals 20, x is equal to 5. If I plug in x into my expressions, I get 37 here and 37 there. So you can say that angle 1 is congruent to angle 7, and remember, these two angles are alternate exterior angles. When you have two lines cut by a transversal and the alternate exterior angles are congruent, we can say that lines M and N are parallel by the alternate exterior angles converse.